have discussed that we can classify the study of medicinal chemistry into three parts. One is the physicochemical properties, another is the drug designing, and another is the different categories of drugs that we are going to discuss. Now today we will begin from this video lecture. We will begin with physicochemical properties of drug molecules. Physicochemical properties. Now from the name itself we can understand that physico means physical and chemical is obviously the chemical properties. Chemical properties of the drug molecules. Now we know that in a solid molecules have different physical properties and different chemical properties. In solid molecules we see that there are different functional groups and different spatial arrangement of the atoms within the space. So the solid molecules, they have different spatial arrangement of atoms in space. Now, the biological activity of a drug molecule is solely dependent on the physicochemical properties. The biological activity of a solid molecule is solely dependent on its physicochemical properties. Now, we see that in medicinal chemistry we can modify the solid molecules. We can modify it by changing the chemical composition of the molecules. Now we change it in such a way that the chemical modification parallels the activity of the actual solid molecules. That means whatever we will modify the compounds, modification of compounds by obviously the three different ways: elimination, substitution, addition. So all these three different steps or three different processes will not change the biological activity of the molecules. Rather than it will parallels the activity of the actual molecules. So these steps, we will, by doing these three steps, we will modify the molecules. We will modify its stability, we will modify its solubility, we will modify everything, but it parallels the activity of the actual molecules. Now here is another term that is we can use here called bioisosterism. Bioisoster, that is the replacement of the compounds with replacement of the carbon compounds with an equivalent biological activity atoms, such as we can change the carbon molecules with the nitrogen, the carbon atoms with the nitrogen atoms, so that the biological activity is not lost. The biological activity remains same. So bioisosphere, we can modify it by changing carbon atoms with other atoms that will not hamper the biological activity. Thus, the isostatism is another modification that we can do to the chemical compounds to modify its activity. Next, we are going to discuss about the pharmacological and therapeutic effects of a drug depends upon the physicochemical factors. So we are discussing some of the physicochemical factors. The most important that we have discussed is bioisostatism. Next is hydrogen bonding. Third is chelation, that is the complex compound. It is also known as the ability of the compound to form chelation, that is, we have already studied in class 12 that it is a complex compound, that is chelations, complex formation. Fourth is the surface activity. So these are the four physicochemical factors that generally influence the biological activity of a therapeutic molecule or drug. Next we will discuss about Ferguson principle. This principle arises from the fact that many of the compounds of different functionalities, having different functional groups, have similar biological activities, such as narcotic action, second is the anaesthetic action. Though they do not belong to a specific functional group, they may vary, the functional group may vary, and different chemical compounds of diverse functional groups may exhibit these two anaesthetic action and narcotic action activity. But we see that does not solely depends on the physical properties of the solid molecules. As long as the concentration of narcotic concentration and anesthetic concentration are removed from a specific concentration, we see that the effect suddenly diminish. That means the diminution of sudden biological effect occurs. This tells us the fact that the physical properties are more important. Physical properties influence the biological activity. any of its chemical nature. According to Ferguson, it is impractical to know the chemical nature of the molecules, but if we know the equilibrium state or the thermodynamic activity of the particular molecules, we may get the biological activity. That means important is the equilibrium state. It is not necessary to know the nature of the biophase or the nature of the receptor. It is solely depend on the thermodynamic activity. So we can get the thermodynamic activity and we can calculate or we can determine the biological activity. Now we know that solutes are of two types. One is volatile nature, and another is non-volatile nature. The tendency to escape in case of volatile nature of solid molecules is more than non-volatile molecules, where there is no tendency of escaping. So we know that for volatile nature we can easily calculate the thermodynamic activity, and for non-volatile nature we slightly use a different formula which we will discuss later on. In equilibrium state, the tendency to escape from one phase to another phase is same, although we have different concentration. Concentration of solute in each phase. That means that equilibrium concentration is not relevant. Here only the equilibrium state. Important is the equilibrium state. And thermodynamic activity. Now we stated that compounds of different functional groups can have similar biological activity. That means we can divide solute into two parts. One is structurally specific. Structurally specific, that means which have a specific structure, a specific category of drug molecules that gives anesthetic or narcotic action, and other is non-specific drugs, non-specific solid, non-specific solid. So we can classify it. Structurally specific and non-specific. Now, for structurally specific molecules, thermodynamic activity is necessary. It does not depend upon. Value depends upon. Value is less than, sorry, 0.01, and it ranges, for non-specific it ranges from 0.01 to 1. More modification through chemical intervention increases activity. Chemical modification does not increases much activity. Here, structurally not specific, we know that the structure is not similar, right? So, chemically diverse structure of the solid molecules. And here is the structural similarity. For those compounds that actually gives the narcotic and anesthetic actions. Sorry, I have here misspelled something, that the thermodynamic activity is depend more in case of non-specific drugs. So it depends more. And thermodynamic activity is not so important in case of structurally specific So it is not important. Sorry, it is not important. In the next video, we will do an example to understand this for your better comprehension. Thank you.